All right, good morning. We're going to continue talking about we're going to start talking about simplifying radicals. So what are radicals? Well, first off, this right here, let me get up. This right here is our radical symbol, okay? Depending on what our number here is, will determine what type of radical we'll have. We will be dealing with mostly square roots. So that's our radical symbol. Okay, underneath is what we call the radicand. So this is anything that's under the radical sign. Any number that's sitting in front, just like when we had variables, is called a coefficient. And then if we have a number here, that is our index. Now note, if the index is not written, we're going to automatically assume it's a 2. So these are the parts of our radical. Now again, mostly what we will be dealing with is an index of 2. Okay, so to simplify a radical, we are going to look at finding the largest perfect square that will factor, that is a factor of our radicand. So we'll talk here in a second about what perfect squares are. Remember, this is the number under the radical. So then we're going to write that factor pair under a square root. And we have a rule that lets us separate that square root into two things because they are multiplying. And from there we can simplify because one of those will be a perfect square. So these are perfect squares. Basically, if I take a number and square it, that gives me a perfect square. So like 1 squared is 1. 2 squared is 4. And so on. I'm not going to go through all of these. Those are all perfect squares. So if I take the square root of those numbers, then I get out what was squared to get them. So square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, and so on. Now there are more perfect squares than this. This is not the whole list of perfect squares. That would be impossible to list out. So, all right, so we're going to look at this first, and we're going to take the square root of 24. Now, I know 24 is not a perfect square because 25 right here is a perfect square, right? So I'm going to look at factors, two things that multiply together of 24. So I'm just going to list them out. We've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. 5 is not a factor because 24 does not divide by 5 evenly. So what are my perfect squares here? Well, I really only have one perfect square, and that is 4. So we're going to take 4 times 6, and we're going to put it under a radical. Okay, so because we are multiplying, I can split that into 2 radicals. Now, I know what the square root of 4 is, okay? Square root of 4 is 2. So square root of 6 doesn't simplify anymore. Its only factors are 2 and 3, and neither one of those are perfect squares. So my answer here is 2 square root of 6. Okay, let's look at another one. I've got square root of 32. Again, we know it's not a perfect square. It's not in our list that we, Okay. So we're going to look at factors of 32. 1 and 32, 2 and 16, 4 and 8, 4 and, So those are my only 2 factors, or only 3 factors here I have. 5 doesn't work, 6 doesn't work, 7 doesn't work. And then we get back to 8, so we know we've taken care of all the factors. Okay, so 4 and 16 are my 2 perfect squares. I want to pick the largest because otherwise I don't get it simplified enough. If I took 4 and 8, well, 8 also has another factor of 4 in there, so I would still have to simplify more. So I'm going to pick 2 and 16. Now, I'm always going to put my perfect square first. It's just going to make it easier when we get to things that have coefficients. So again, I can split this into 2 because I know rules of multiply, right? And I know the square root of 16 is 4. So my answer is 4 square root of 2. All right, let's look at another one. Square root of 400. I want to talk about something. This is a really big number. Okay, so factors are 1 in 400, 2 in 200, 4 in 100, 5 in 80, 8 in 50, 10 in 40, 16 and 25. All right, so we have 4 sets of perfect squares here. I will say I'm leaving out a certain factor for the moment because I want us to look at something. Because we're not always going to be able to quickly see unless some of our numbers are going to get way too big to list all the factors. So I want us to look here. We've got 4 and 100, 16 and 25 as perfect squares. Now I'm going to use the 16, 25 because they're smaller numbers than 100. But I could have used 4 and 100 and this would work just as the same. So if I take square root of 16 times square root of 25, that's going to be 400, right? So because of rules of multiplication, I can split those up, which would, square root of 16 gives me 4, square root of 25 gives me 5. So I would get 20 as my answer. Now, if I had gone one more step, I would have seen, right, that 20 times 20. So a lot of times when I have a perfect square number that's really big, we're going to find that 2 perfect squares multiply together to give you that number. Or you will find that number times itself. Okay. All right, so let's look at another one. 17, I know this is not a perfect square. The only factors of 17 are 1 and itself. So the square root of 17 is already simplified. There's nothing else I can do. It is just going to stay the square root of 17. Unless I want to put it in decimal form, which I could. But we're going to leave it as a perfect square, or as a square root. All right, so now let's look at some that have a coefficient. So I've got 4 square root of 18. 18 is not a perfect square that I'm aware of. So let's look at factors of 18. So 1 and 18, 2 and 9, 3 and 6. 9 is my own only perfect square. 4 didn't work, 5 didn't work, and we're back to 6. So we know we've got all our factors. 9 is my only perfect square. So I can split this into the square root of 9, square root of 2. Again, I like to put my perfect square first because remember, order of multiplication does not matter. But I like to put that first because it's going to come in handy when we deal with the multiplying the coefficient. Notice our 4 is not dropping out. We still have that there, okay? So 4 times the square root of 9 times the square root of 2. Now we know what the square root of 9 is. It's 3. So now I'm left with 4 times 3 square root of 2, which just means that 4 times 3 is 12 square root of 2. And there's my final answer. All right, 3 square root of 60. So looking for factors of 60. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. That's what I thought. Okay. 7 doesn't work, 8 doesn't work, 9 doesn't work. Okay, those don't divide out evenly to a whole number. All right, we only have one perfect square, which is 4. So we're going to split this into 4 times 15. So we get 3 square root of 4 times 15, which again, we can split those into 2 square roots. So I get 3 times the square root of 4, which we know the square root of 4 is 2. So we get 3 times 2, square root of 15. So I get 6 square root of 15 as my answer. All right, 225. So I've got 3 square root of 225. Now 225, I'm going to point out, is a perfect square, okay? But let's say we didn't see that. Let's look at our factors. We've got 1 and 225, 3 and 75, 5 and 45, 9 and 25, and 15 and 15. So this right here is 2 perfect squares, right? But 225 is a perfect square because we could say 15 times 15, or, so we end up doing, because 225 is a perfect square, which taking a number times itself, so square root, or 45 is our answer. We have a whole number with no radical left.